Hello everyone, I'm Vivek Raja, host of today's session from Azure Community, Tamil Nadu. I'm working as data scientist at a startup called Nextem, and I'm an organizer of Azure developer communities in Tamil Nadu, such as Madurai, Chennai, and Coimbatore. I welcome you all for today's session here, and I'm having a wonderful guest today who is Ameer Jhan. Uh, So about Azure developer community, so we are currently operating in more than 100 cities here, and we have more than 300 500 members currently. And the best part is we have more than 400 members from Azure community in Chennai alone. So as we compare, take into consideration, there are 12 communities in Tamil Nadu, and we collaboratively work together and host events with other organizers as well. And we are very much proud to say we are now currently 400 members plus in Tamil Nadu itself, in Chennai. So what we do is that we host online meetups. We bring in experts on different topics, and they deliver content and sessions, and also they interact with audience to get started with stuff. And we have an excellent community of both beginners, professional, and experts in various topics in cloud, Azure, machine learning, and stuff. So you're always free to join and interact with us and get your knowledge shared and gain knowledge as well. And also, we have a special series which is running in our meetup, which is called Azure Certification Study Jam. We understand the importance of certifications in the current industry scenario, and we are very much looking towards that. And we also help this various professionals to attend the exam and also get current resources and help to clear the examination. And best part is we also provide few free vouchers based on contest and stuff. So always stay tuned, and you might also win a free voucher for the exams. And also, we have a other special series called Corporate and Startup Talks, where we invite architects and founders of various corporates and startups. They will be discussing on how they are running their organization with the help of cloud and other supports. And podcast is going to be started very, very soon. So please tune. And fun contests are getting organized every single week. So we conduct on various bases, and the winners get various perks such as it might be Azure certificate voucher or maybe Azure free passes and etc. And the best thing is like you're always welcome to come and present or share your knowledge and everything. Yeah, the stage is always open and we welcome you all. And in today's session, we have Ameer Jhan, who is an ex SDE at OLX Group. He is personally my well-wisher and a mentor, and he is a very great technophile. Please do check out his GitHub profile, and you know how he's excellent at that. And he'll be presenting on the topic called containers for rest of us. We'll be deep diving into that from the fundamentals and stuff. So I welcome Ameer Jhan here. So stage is yours. Please take forward.
Hey Vivek, thanks for having me. I'll just quickly share my screen. Hmm, Let me know if it's visible.
Yeah, visible.
Awesome. So let me just quickly start with the channel. Yep. So hello everyone. Great to see you all. Thanks for joining today, and hope you are staying safe and well in this pandemic. So before we start, just let me just break the ice by sharing a little about myself. I'm Ameer. You can find in most of the social platform using the handle Amit the Hacker, and I work used to work as a say like ST2 at OLX people. So it is kind of an organization which connects blue collar workers with huge organizations like Swiggy and Amazon. Right? So I used to be a full stack developer where we work on interesting problems like automatic application screening, recommendation engine for jobs and stuff like that. And when I'm not working, like I maintain a proper React library called React Lazy around like 4K stars. And I also build a lot of small tools here and there. You can find them in my GitHub profile. And if you like, probably you can contribute to it also. And I write a lot in free code camp. So check out my articles if you like it. Clap is always welcome. And I'm a huge Marvel fan. I have some good-looking cats just sleeping beside me. And I'm a huge sticker nerd. If we were like meeting in person for this, you would see a lot of stickers on my laptop. So that's what I do when I'm not working. And today I'm gonna briefly talk about containers for REST office. So before we will start, let me just like share what is actually behind this whole title, container for REST office. So I personally believe that containers are hugely misunderstood in a fundamental level. We all do use containers in our daily life in one or another way, but we do not fundamentally understand it. That leads to a lot of confusion of why this is possible in containers, why it's not possible. Like then, what is the whole idea of like VMs? Are containers VMs or micro VMs? Why should I use VMs not containers? Why should I use containers and not VMs and things like that? Right? So if you take if you do a normal Google search and look for the definition of container, this is what it says: containers are isolated from one another and bundle their own software libraries and configuration files. Even though it kind of looks okay, but it doesn't give you the entire gist of like what's actually happening underneath the surface, right? This is just like a tip of the iceberg. This definition is, but today I think we can kind of go deeper into the rabbit hole and understand what actually this means, right? Not just on the surface level, but let's just dive into the rabbit hole. And like we're gonna go on a journey, right? And in the first step of the journey is to forget containers. Like someone wisely said that to understand containers, the first step is to forget about containers. Don't care about containers.
Excuse me, Amir. Sorry to interrupt. Can you keep your mic a little bit closer so your voice is a
Okay.
little bit big?
Okay. You're not able to. Yes. So is it clear now?
Yeah,
Yes.
yeah,
Is it
better.
clear?
Yep,
Okay.
better.
Cool. Awesome. So today we are going to go on a journey. The first step of the journey is to forget about containers. Don't care about containers at all. Right. And the step two that we're going to do is we're going to build the following. Okay. And the goal of this build process is going to be we're going to avoid a program from killing another processes. Okay, so we're going to start a program and we're going to avoid the program from killing other processes, and we're going to make sure that program cannot update the host name of our machine. Like host names are nothing but unique names that are given to each machine in a network, and we're going to avoid that program from reading some secret files. I might have some super secret files in my machine, and I'm going to avoid that avoid the process from reading it. Right. So that's what the goal of this entire talk is going to be. We're going to just do that. Don't care about containers for now. Right. Before we start to build that, we need to have some like few things set up right understanding of few stuff. So have a look at a basic C program that I've written here. It's going to try to open a file called file.txt. It's a simple C program, right? But underneath it works like this, right? In C program you call it as fopen, but it is actually getting translated into an OS specific syscall. Syscalls are nothing but APIs that are exposed by a particular operating system's kernel. Like if you take Linux, there is a system called open, which allows you to access the hardware, which is the disk, through the kernel, right? So here you can see I have drawn a small line which says like user space and kernel space. So whenever you're doing things in your application, it's going to stay in the user space, but the time you're trying to access hardware like network, file system, and things like that, it's going to switch to something called a kernel space. Kernel space is more privileged than user space, so it has access to hardwares like maybe your keyboard, mouse, disk, and stuff like that. So every C program, like even though they look similar, they do different system calls to do things that are supported by the kernel. Right. So then what actually a space is, like what actually space means. Space, you can kind of imagine it as like an abstraction of resources, set of resources. Like if you take any program, when you run a program, it's gonna have access to certain level of resources. If you run a HTTP server, if you run a HTTP program, it's gonna have access to your network. If you run a linter or some kind of program that's gonna access your file system, it's gonna read your file system, it's gonna have access to the file system. Okay, and in Linux, these resources are further separated into namespaces. They group similar resources into their own namespaces. Like for example, network is a namespace in which all the resources related to network are jammed together, and there's something called process ID resource in which like a process has access to all the other process related stuff, like what are the other processes running in my system, what are their process IDs and stuff like that. And we are going to also have a namespace called mount. Mount is nothing but a file system. So this namespace has all resources related to a file system. Right? And then Unix time sharing is nothing but, if you remember when the networking came first, they used to have a single huge Unix mainframe running somewhere, and a lot of clients used to connect to it, and they were doing something called a time sharing, right? The same machine is going to serve all the clients based on some time sharing mechanism. So that kind of still lives in our Linux system even today. So that's called Unix time sharing stuff. So that's grouped into that namespace. Okay. So by default, whenever you run a program, like let's say you're running a bash shell, or any other program, HTTP server, they're gonna by default run on a global namespace. The global namespace is gonna have access to all the namespaces. Like it's gonna have access to your network, your process, everything, right? But the cool thing about Linux is that it provides you a special system called unshare. Right? Let's say the program one uses the syscall called unshare to fork a new process. By forking, I mean it's going to create a new process, which is a child process. Okay, so it can tell the Linux kernel that, hey, kernel, you know what? Don't create this in a global namespace. Create a new namespace for this so that the resources are not shared. If multiple programs run on the same namespace, they're going to share all the resources. But the moment you create a new namespace, for example, you create a new network namespace, the network is never shared again. If you create a new file system namespace, the file system is not shared between the program and the child process. Right? So this kind of adds some layer of security between the programmer and child process. The child process cannot abuse your resources because it has a different namespace. It may not have access to the to everything that other process have, right? And this kind of helps us. This unshared system called already kind of helps us to achieve what we're trying to do here. Like we want to avoid access, like killing other process, not updating the host name, not reading a secret file, right? So that the secret source is nothing but the unshared files, the system called that Linux provides, right? And you may be thinking like, theory is not so interesting. It's gonna be boring. So enough is enough. Let's like quickly do a demo. Okay. So let's do this in a practical way, not in a theoretical way. So I'm gonna just quickly switch to my browser. So all the things that we are doing right now is going to work only in a Linux machine. So you can probably create a virtual box, create a Linux box out of it, or maybe run a VM. So I'm running a Linux VM in Azure. Okay, it's cheap. Like the trial gives you a basic free VM for a year. So I have a terminal here, and I'm going to SSH into that VM I have. So I'm going to SSH into that VM, and I'm into that Linux VM. So I'm into the home folder. Now let's start with our first goal is to avoid a process from killing another process. Okay. So first of all, what I'm going to try to do is that I'm going to create a process. Okay. So I'm, you know the top command, right? The top command gives you the list of all the processes running in your current system, and there is a way by which you can.
Hi, Amir, just one more thing. Can you zoom the terminal so that we can see the commands a little bit?
Sure. Is it visible right now, or should I zoom a little bit?
Yep. This is very much better. Yep.
Cool. Awesome. So I'll go once more. Like top is nothing but a program that gives you idea about like what are the process running in your system. Okay. So you can make any program in Linux, like kind of run in the background using the command, like by adding ampersand at the end. So what it makes is that it makes top run in the background. So if I do PS, which is can list all the programs that are running in my Linux box, it says bash is running, obviously my shell is running. I try to run PS, so that's also running, and top is the command that we ran in the background. This is the process ID that kind of was assigned by Linux, right? Now let me start a new program. Okay, so what I'm going to do is that I'm going to start the SH shell. Okay, this is a new program that is started from a bash shell. So I'm into my SH program. Okay, now what I'm going to do from the SH is that I'm going to do run PS. Okay, so now you can see that I can still see the top process running. I'm going to try to kill it. So the process ID for top is this, and I killed it. Now I should do PS. it's gone. If I come outside of the program and try to PS, and it's gone. So now I started a program, and the program have access to the process resources, and it was able to kill a process. This is a huge security breach, right? Now I have a requirement that I don't want this particular process, which is SH, a shell, to access the list of process and kill them. Okay, so that's where the unshare system call comes. Thankfully, there's no need for us to write any code to using it. There's already a handy program in Linux, which is called unshare. Okay, so unshare, you can use unshare help. So it's a utility that comes along with the Linux operating system, and it's internally it's using the the unshare system call. So now you're calling unshare, it's going to call the unshare system call internally, right? Now what I'm going to do is that I'm going to tell unshare, okay, unshare, you know what, whenever you're creating a new process, forking a new process, kind of create a new process namespace so that this process has no idea about my current processes, right? The way to do that is use unshare, use PID option, which means that it's going to create a new process ID namespace for whatever it's getting forked. And I'm going to use the fork option, which means that it's going to fork the process, fork a new process. So what it's going to fork, it's going to fork a process called SH, the SH shell that we did previously. So the difference between this and that is that now SH, the program is going to be forked by the unshare, but at the same time, it's going to create a new process namespace, right? So before we do this, let me again try to run the top in the background, and you can see top is running in the background. It's the PID is right there. So I'm going to copy the unshare command that we are trying out, and I'm going to run this in sudo because unshare runs only in sudo. So unshare is going to unshare the PID namespace, fork a new process, which is our SH shell. Right? Sorry, I made a small typo there, so I'm going to just remove that slash from there, and let me run it. So we are in a SH shell. We are root. Okay, let me do PS. You can see now the top is gone. Top is not listed here, right? All that is visible to this is the process that was started by this fork process SH shell. There is no top in this, so there's no way by which I can kill the top process, because this whatever that got forked has no idea about my process namespace that was global. Now it can't kill the top process. If I exit from this and I do PS again, now you can see my top is still running, right? But the new process program that I started, bin/sh using unshare, was not able to view it. So we already brought a layer of security to our program by which it cannot kill other processes, right? So first priority check. Now we cannot kind of kill the processes in our global namespace since we create a new namespace using the unshare command, right? Now let's try out another thing. I'm going to use a command called hostname. It kind of prints out whatever your current hostname is. Hostname is kind of uniquely identifies your machine in a set of network devices. So you can use the same command hostname to update it. Like you can say something like hostname, a new hostname, like let's say containers talk demo editor. Now that can be done only by sudo. That makes sense. Now I do it, and I'm gonna. You can see it got edited, right? Now what I'm going to do is that I'm going to use the same unshare command, okay? And now if I try to access the host name, I'm able to access the host name, and I'm going to try to update the host name, right? Let's say from my child process, I'm going to say I'm updating the host name, right? I'm going to exit it, and I'm going to say host name again. You can see my child process was able to update the host name of my my machine. It shouldn't have access to that. That's our next motive is, right? So to do that, we can use another option in unshare. You can use the help command of unshare to always look into it. And here you can see something called UTS, okay? Unshare UTS namespace, which is nothing but host name. So using this, you are creating a new time shared namespace for the child process. So the child process wouldn't be able to update your host name. And now I'm going to do the same. I'm going to take the fork, but while doing the fork, before I'm going to also create a new QTS namespace. Right now, if I do host name, it says hack. I'm going to say host name hack again. The host name. Now the host name says hack again. But if I exit and try to run the host name from my parent process, it doesn't get updated. Right now, we protected the list of processes. We protected the host name from the child process. So whatever program you're going to execute using the unshare command, which is going to get forked, it's not going to have access to the list of processes running your machine. It's not going to have access to the host name of your machine. It can update it, but it's not going to actually get reflected. So we already added 2 levels of security, right? So everything in Linux is kind of namespace. If you create a new namespace, you are creating a new security, kind of a barrier, right? Let me just drink some water. Okay, so we already achieved 2 of our goals, right? We separated the host name. We separated out the list of processes from getting access in my child process. Now the next big challenge is, let me touch a new file, supersecret.txt. Right, I'm going to open it in my Vim. Let's say it has all my .secrets, and now I can see there is a super secret file right now. Let me try to run the unshare. If I do ls, you can see there is a super secret file. I can cat into it. Sorry, I need to fully type it. That's a problem with sh shell super.txt. Okay, now I'm able to read the file, right? This shouldn't be happening, right? File system is also a resource, and we should kind of separate it out from my child process. So how we can do that? Right. So there is another useful command in Linux called change root. chroot. Chroot kind of helps you to switch your entire root file system, right? If you see in Linux, the file system is a root file system. It starts from the root, it has home folders, it has etc folders and things like that, and it kind of keeps branching out. So one way what you can do is that for the child process that's executing, you just switch out your current root folder into a different dummy root folder. So whenever the program is trying to read from any path, it's going to read from the dummy folder. It's not going to read from your actual file system. So what I can do is that I'm going to create a new folder called dummy rootfs. Okay, and in the dummy rootfs, I'm going to switch my current root of my Linux machine to the dummy rootfs. Right, I can use the command chroot and dummy rootfs. Okay, but we get this error called cannot run the command /bin/bash. But if you see, I have the file bin/bash in my Linux box, but it is not present in my dummy rootfs. My dummy rootfs doesn't have a bin folder and doesn't have a bash file, right? So one thing that I can try to do is that I can copy the bin/bash file, okay, into the dummy rootfs, right? Into a dummy rootfs. Actually, I need to create a bin folder into it. So what I'm going to do is that I'm going to create a bin folder inside my dummy rootfs. Okay, so if you do ls of dummy rootfs, there is a bin folder. So what I'm going to do is I'm going to copy my bin./bash into the my dummy rootfs/bin. Okay, so now if I do dummy rootfs/bin, I should have my bash file over there. So I have a bash executable there. Now let me try to do the chroot command. Right? It's still not able to access it. Bin/bash, I did copy it. Okay, so it's not just the bin./bash, right? There are other configuration files that are required by the Linux system to understand like how to execute bin/bash, right? So this kind of proves that you can't just copy a single executable from your machine into a dummy rootfs and do things, right? So for that, we're going to need a kind of a root FS that you can replace it for your current root, right? So for that, we're going to download something called an Alpine toolkit. So if you go into the downloads of Alpine Linux, you would see three stuff. Standard, which is nothing but the entire operating system for you can download it, boot it, things like that. And extended for other stuffs. And if you come at the bottom, you will see something called mini root file system. This is what we're looking for. We just want the root file system. We don't want the entire operating system. And they are actually kind of specify this for this is to be used in containers and minimal codes, right? So we actually need this. We just need a dummy file system, which we can use it instead of our actual file system. So I'm going to use this option, x86-64, which is our Intel architecture, and I'm going to copy that link address, and I'm going to download it in my VM. So I'm going to use wget and copy it, and you can see the zip file is available in my Linux VM, and I'm going to kind of unzip it now. So I'm going to use tar. I'm going to extract it. I'm going to extract the file, and the file name is going to be the Alpine, this one, and I'm going to copy the content into a file called dummy rootfs, right? So before that, let me just remove the bin folder into it in the dummy fs, which we actually don't want, and I'm going to extract it again. Extract it into our dummy rootfs. And if I do ls of rootfs, you can see we have a Linux root file system sitting inside dummy rootfs. Okay, but this is just a minimal file system that is required for any Linux operating system to work, right? If I do an ls, you can still see I have a super secret txt, right? So now let me just run the chroot command, and I am gonna change it to dummy rootfs, right? The thing is that this Alpine root file system doesn't have a bash shell. It just has a sh shell. If I do ls of dummy rootfs bin and grep it for bash, it wouldn't find anything. But if I do it for sh, it should find something because we have a shell executable but not a bash. So one way we can do that, we can just say that change it to root, but try to execute this shell, not try to execute /bash, right? That's the second argument. So if I say bin/sh, now you can see I got into an sh shell. If I do ls, you can see I'm into altogether different file system, right? I'm not seeing my super secret file anymore, right? If I do ls, I can do this. It's the file system that we downloaded by creating a new file inside my dummy rootfs, right? I'm going to go into the dummy rootfs. I'm going to attach a new file. Let's say new root.txt. And if I come back and run our previous command of changing the root, ls, you can see we have new root.txt. From this program, this sh shell cannot access my actual root file system, and it cannot access my secret file system, right? That's more powerful, right? You're creating a new program and it has no access to your actual file system, but it has a file system of its own. So all the things that it's going to try to execute or access is just within this file system. Right? But still, we have another problem. Let's say I'm trying to update the host name. I'm going to say hack from dummyfs. Right? And I exit. If I check out the host name inside this sh shell, the host name is updated. If I exit and check the host name got updated. We just protected the file system. We did not protect the the entire machine. So how do we do that? It's pretty straightforward. We just combine the chroot with the unshare command that we were already running, right? So I'm going to just quickly use the app arrow like everyone else and just find out the last command that we ran for unshare. Right? So this is what we are trying to do. Right? So in unshare, we separated out the PID, we separated out the UTS, and we created a new fork. We were running bin/sh. Rather than running the sh shell from my current file system, I'm gonna use the sh from the dummy root file fs. So what this single command does is that it kind of creates a new namespace for process, it creates a new namespace for network, it creates a new namespace, and it creates a fork of my sh, which is inside our dummy root fs. Right? If I do that, if I do ls, you can see this is my new root file system. It has no access to my secret file. At the same time, if I try to update the host name, you can see the host name is hostname from dummy. If I say hostname hack again, something like that. If I see the hostname inside this process, it says hack again. If I exit and try out the hostname, it says hack from dummy fs. So our process, which had a new file system, did not have access to our hostname. It could update it, but it was not reflected. So if you see right now, we kind of isolated a program in 3 ways. We isolated it from our root file system, so it cannot make harm to our actual Linux box, and we isolated it from network, so it cannot update the host name, and we isolated it from the process namespace, so it cannot kill other processes. So in this way, you can sandbox a single program which you think might be malicious or something can harm to your system in a safe sandbox manner. And all this is running inside your Linux machine. You didn't use any third-party tool or anything like that. The reason behind that is it's baked into the Linux operating system itself. The Linux operating system provides you a system call that lets you to sandbox a process, kind of like it's kind of an illusion. The process is kind of talking to the kernel. The process trusts what the kernel says. The kernel kind of puts up an act saying that, you know what, I don't have any process that I can share with you. Or it says, okay, I have updated the host name, but in reality, the kernel never updated the host name. It just told the process it was successful. But the kernel knows that it was in a sandbox, the process was in a sandbox, so it did not update the host name and just gave it was a success signal. And the process was trying to read the file system, and the kernel knew that, okay, the program which executed you told me to switch out the file system, so this is what the file system you should see. And it kind of the kernel hid out all the secret files that the process should not be seen, right? So it was all done in the kernel level, right? So does anyone have any question till now? Like we have already made a breakthrough, so does anyone have any questions till now? Just quickly check the chat, maybe.
As of now, I guess I can put that in screen. Maybe like you can summarize whatever we've done so far, next agenda of the next following session.
Sure. So what we tried to do, we kind of like executed a process, and we saw that a process could access your secret files, it can access the list of processes, and it can update your host name, which are very dangerous. Then what we did, then we used a bunch of Linux system call, which is nothing but unshare, to unshare your process namespace, unshare your your network namespace, and also switch out the entire root file system of Linux into a new one so that it cannot access your your secret files. Right? That's what we all did. Right? Now let's go back to the slides, and now it would all make sense. Right? Now let's build a mental model. Unshare command was nothing but your container runtime. So all the container runtime that you read on the internet does exactly this. It just uses the unshare system call to just unshare the namespaces so that the process doesn't see everything that it can. It just isolates in a way that it just sees things that you intended to see, or things that we tell the process to see, right? And container is the Docker's container runtime. If you have heard about Docker, Docker is a huge player in the containerization industry, and container is their version of the runtime, and it does a lot more than what we tried to do. Okay, there is a huge lot of namespace in Linux, not just for 3 namespaces we did like process, network. There's a hell lot of namespaces, and Docker container engine kind of isolates all those namespaces. So whenever you run a program inside a container, it's nothing but it's using the Linux unshare system call and just kind of isolating, kind of creating an illusion that the program sees nothing that the current system has. It just sees things that the container runtime actually wants it to see, right? If you see, we had a root fs. We took it from Alpine, right? we took it from alpha and a root file system and we switched our entire file system. That's nothing but your Docker images, right? Your container images, they are the root FS. If you see, you have a alpine image, you have a Ubuntu image. They are not operating systems, they are just tools, the root file system. They don't have the entire operating system, they don't have boot configuration, stuff like that. They just have the root FS, so that you can switch your current machine's root FS for that. And now all the program that you're running just sees the dummy root FS and it cannot harm your system, right? That's the mental model that we built. And now this answers a lot of questions that we always have about containers, right? Like, why containers are faster than VMs, right? Like, containers also provide some level of security. But since containers are actually processes, they are not VMs, they are another process. If you run a C program, it's going to run in a second. Similarly, containers are nothing but another process, so it executes in milliseconds. That's what we say, like, containers boot up in milliseconds, because they're nothing but another process. Containers are not special, they are just another Linux process. So when you download Ubuntu or Alpine images, you are just downloading the root file system. You are not downloading the entire operating system. So if you take a VM, if you're downloading an ISO like Ubuntu ISO, or if you're downloading a Windows ISO to run it in your Oracle VirtualBox, you are downloading the entire operating system, the boot configuration with all those setup. But when you download a Docker image, you are just downloading the required tool set, just the tools and the binary files that you require to run. So Alpine, it just has bin files, all the required files for Linux to run those ls commands, cat commands, and stuff like that. And container images are built for one OS, right, and cannot run on another, right? Like, unlike VMs, these are just another programs. So every program has a platform dependency. So if you build a program that's specified to run in Linux kernel, then it's gonna require a Linux kernel system call. So that's why containers built for one OS cannot run in another, because they're just another process running in the OS. A process always have dependency on the OS that they're running on. And if you think, Windows and Linux are the only operating systems that provide a container like this unshared commands and system calls natively. macOS has no support for that. So if you're trying to run Docker in your macOS, you can see there's a separate virtual machine created for you, right? It's a Linux virtual machine, and all your Docker commands are kind of proxied into that virtual machine. So unless, if you're trying to run a Linux image inside your Windows machine, you can see that Windows actually kind of creates a Linux VM in your, I think it's in your hyperware or something like that, in Oracle VirtualBox, right? So you can never run a Linux container inside a Windows machine without a VM, right? So this is why, this is the reason, because all it uses is nothing but an unshared system call. It needs Linux to run that, or the system call which is specific to Windows and things like that. So that's all, folks. So what we saw is containers. What we did is a container. We just used the unshared system call, which actually kind of kind of creates an illusion for the program, not seeing the resources that you don't want it to see. So that's it from my side. I'm open for questions.
Yep. Hi, I'm back again here. So that was an amazing session. So from me personally, I have been working a little bit with containers, and I know the analogies and stuff, but I never had this kind of an in-depth understanding of how you really do here. So we got a couple of questions. That amazing session, and hats off to you. We'll take one or two questions here.
Mm-hmm.
So we have a question from Vishwas. So he's saying, like, can we have a root password set for the user so that it can give only access to a particular file to the system we have downloaded, the Alpine file system? So,
Okay.
So basically to summarize that, it's like giving authorization to particular containers for specific persons.
Okay. So containers kind of don't work with authorization themselves, right? Like, they are nothing but child processes. So what you can do is that, like, you can specify the authorization to the program that is actually, kind of triggering or forking the child process. We were calling unshare with sudo, right? So whatever the container that was running with root access, right? So what you can do is that you can kind of adjust the authorization in a way that unshare has access only to set of files or things like that, and then use unshare to call other programs, and the programs would inherit all the rights from the parent program, right? Does that make sense?
Yep, perfect. Okay. Next question is from Balaji, who has been active
Mhm.
from the beginning of the session. So his question is, isn't the Windows also running a VM for Dockers?
Yep,
So
that is true. So if you actually like if you check closely, Docker support natively for Windows just came little late, right? Containers were supported in Linux for a long time, but the native support for containers in Windows came out of beta few, I think maybe few years ago. Okay, so if you see in Windows, there's an option to run Windows container and also Linux containers. So if you use Windows container, by default they're going to run natively. They're not going to use any VM. But if you switch to a Linux container in your Windows option, it is going to internally create a new VM for in hyperware or in VirtualBox. When I was using it, it's going to use a VirtualBox to create a new Linux VM, because Windows doesn't know how to execute Linux system calls, right? Because they're end of the day Linux programs. So that's why you see VMs in Windows machine when you're running Docker. But if you see in Mac OS or Linux, you cannot run Windows containers at all, right? Because it is not easy to create a Windows virtual machine because they are licensed. But if you take the other way around, in Windows you can create a free virtual VM for Linux because they are free. But if you take in Linux, you can never run a Windows container because you can't create a kind of like Docker by default cannot create a VM for Windows. But you can go around it. You can download a licensed version of it, do some kind of plumbing work to get it working, but by default it's not supported because Docker cannot run a Windows VM in Linux.
okay, perfect. So we have one more question from Balaji. So
Mhm.
his question is, so if the Dockers are especially built for Linux, so is there any proprietary hardware that supports containers? So by proprietary, he means like uh, this one. So
Okay.
I guess, can you get the whole question?
Yep, I can get your question. So the idea is like the containerization is kind of set of standards. Okay, so whatever operating system that is supporting that standard can do this. Okay, there is something called an open containerization initiative, in which they say that okay, if you want to support containerization in your operating system, then you need to follow all these specifications. Okay, so Linux was the first one to come up with all the specification to support it out of the box. Then Windows came along and they supported all the specification. They now run the containers natively. Okay, so whatever operating system that you're talking about, proprietary or open source, as long as they support those specification, kind of build those into their system calls, they can also support containers. Okay, and there is then people who are working on containers should build kind of a container runtime for that particular operating system. Then they can run containers out of the box. And
Okay,
until
perfect.
that time, they have to just run a VM of Linux, because VMs Linux supported, and proxy all those container data stuffs into Linux and learn containerization.
Awesome. Okay, awesome. From the comment section, I guess we don't have any more questions, but people can, I guess, one more question popped up. Okay,
Mhm.
so can we use the container for creating standalone testing environments?
Yep, containers are actually meant for that, because when you are doing a lot of testing, especially end-to-end testing and stuff like that, you don't want your tests to be meddling with your actual system, right? You don't want that. That's why you can use containerization to switch out, bring in a new dummy file system, run all those tests, and then throw the new file system and bring in new file system, right? So Docker containers are meant to be used for local standalone testing, one of the use cases.
Okay, awesome. And can you share the resources that we have seen so far? I guess it's available in your GitHub, right?
Yep.
Yep. Okay.
Yeah, like it's available in my GitHub. I'll probably share with you the website to the deck also. Okay.
All right. So for other repos, go check out Ameer the Hacker. So he has a wonderful profile and repos out there. And when it comes to us, so we actually maintain all the meetups, sessions, all the decks, and whatever activities being going so far. It's transparent in our repo, in my Azure repo called azdev-tn. So this details also will be available in that repo soon. Uh, and before we conclude, we have one more question from Vijay. So, how secure are containers? So, is there any? I can rephrase it a little bit. So, is there any benchmark to say this container is secure and this is not, or something like that?
Actually, that's a really good question, right? So if you see, VMs are the most secure, right? They are running in a altogether secure environment. Everything is like translated into another machine code, right? There's always a question: is VM secure or containers secure? Okay, so containers are secure to a certain limit, but they're not as secure as VM. Okay, but when it comes to like how secure they are, like I would say they are as secure as like the kernel implementation. Okay, let's say there was a bug in the Linux kernel, like that allows a container application to also have access to other stuffs. And maybe there was a bug, the Linux system call said that it kind of created a new namespace was processed, but still it was not able to do that, right? Or like it kind of failed to do that and it was not transparent about it. In that case, the security can go away. Okay, and at the same time there are certain stuff that the containers cannot secure, while VMs can, right? There are only set of namespaces that are supported by containers. There can be certain resources that cannot be kind of like hidden by the containerization runtime itself. Okay, so in those cases it may not be secure, but more
Okay.
for the most of our use cases, containers are well enough to provide isolation. So it's kind of an isolated in which one process doesn't step into foot of another, right? But there can be loopholes. They're not as secure as VM.
All right. So actually, Balaji is very much impressed with your presentation and work because he is appreciating your work and
Thank you,
clarity and
Balaji.
efforts you have put in. And one more thing, that's a personal question from me. So
Mhm.
since now we have started with the containers, we know we have understood how it really works behind the screens. So
Mhm.
how can we take it further on the next steps of this container journey?
Okay,
Is there?
so since we right now have a good fundamental understanding and also a good mental model about containers, the first thing that you can do is kind of try to learn Docker. Okay, so Docker is not to be confused with containerization. It's one of the way by which you can learn containerization. There's other options also, but Docker is very popular. So try to read through the Docker docs and try to build your small container. Try to run small containers. Try to like experiment with it. Try to containerize your own application. Right. So the all we did right now is was we took a root file system by downloading it, right, and we unzipped it, and it's kind of a pain. Every time you want a new file system, you want Ubuntu, you need to go search for it, download it. All those things is pain, right? So Docker kind of provides you a good level of abstraction using which it has all the root FS already stored in a central repo, which is Docker Hub, and you can use Docker CLIs to do all those stuffs with less low level handling, like less understanding about the next kernel system call stuff like that. So the next step would be is to learn Docker, try to build your own Docker images, try to run your own Docker images.
Okay, perfect. So we comments are coming in for your awesome session. So thanks to
Thank you,
you.
everyone. Thank you, everyone.
Yep. And personally, a big thanks to Ameer from my side. So because he's kind of a personal mentor to me from my college days. So actually, he's a super senior. So we graduated from same college. So since my college days, we have been a very good touch, and he's been helping me through a lot of stuff. So okay, one more question is, will there be any future session? Okay, I can take you that. Prasad, if you're really interested for that, we can arrange for the future session. So we'll plan on the availability of the session meetups, and we will look out to that. So if audiences are more on number coming for the request, we can definitely arrange for it. So thanks everyone who is in the comment sections telling us about how well the session is. So all credit goes to Amit here. And so this session is done for now. And as a community, what we actually do here is that uh, we, as I said before, we actually bring in a lot of speakers such as Amit to share in-depth knowledge and stuff. And also, if do you really have some questions or need to have a personal touch up or like you need assistance, please do ping Amit. Can ping him through his social handles in either Twitter. He's very much active on Twitter. All his Twitter handles are Amit the Hacker, so you can get to that. And we actually conduct contests, as I said before. So the first contest we conducted last session was the quiz contest. So we had 5 winners there, and we actually distributed the vouchers to the 5 winners. So they are actually going to take up their Azure certification soon. And one more personal thing for me is that, so try to have a good contact, since we are instructed people to come up with their email IDs as a username. It was kind of a difficult to reach out to the original persons, and as there were many claims for the fifth question, luckily we reached out to the original person who actually got the prize. And the second contest which we are going to announce, it's actually long running so far. So you can write any blog or anything related to Microsoft Azure. So you can post it in any social medias, or you can write it in any blogging platforms such as Medium or Dev or anything. So you have to just tag either AZ Dev India or me. So which is Vivek Raja Not 7. So Not 7 actually stands for James Bond. I created it when I was a kid, so I just kept the username as it is. So these blogs will have get a chance to get featured in weekly newsletters we create, and also the best blogs will also receive Microsoft certificate vouchers or Azure passes or swags or many other benefits. And also your blog might get featured in official newsletter if the blog is worth enough. So please do write and express your knowledge. For your better tip, you can write about today's session of what you really learned, or like you can have a code walkthrough of the session we did today. So even that might also really help us with that. So we actually got you covered. So in case you have missed your the meetups, or if you want to have access to the presentation text, and if you want to actually start an open source project in Azure, or if you want to help us in your journey of Azure, like in certifications or even in doubt solving a session, we are actually available in a huge number of network of peoples of experts. So we will definitely love to reach out to you. So you can ping my GitHub repo for all the details and sessions. And also our meetup is very active. You can go check out our future sessions. And personally, I like to say that we actually got featured in Microsoft newsletters thrice. So in the month of April and May. So in the month of May we got featured in my session on containers that was featured here, as well as our meetup demo. The GitHub profile was also mentioned in Microsoft newsletter, which is a personal milestone as for me as well. You can find us in Azure Developer Community using Meetup, Twitter, and LinkedIn. And next session will be on June 11th. So I'll be talking about Azure automated machine learning. So I love machine learning stuff. So I'm starting a new series called Azure Machine Learning, where you can join us with us, and we'll be actually conducting multiple sessions on machine learning. So I'm getting started with automated machine learning because it does not require any machine learning experience to get started with. So for all application developers and machine learning enthusiasts, please do join. And also, as a special note, this is also a part of DP100 certification series, so it will also help you out in that. So until the next time, please stay safe, get vaccinated, wash your hands properly, and also maintain social distancing. Still, we are not out of it, and know the times are really hard. So please stay safe with us. And thank you, and stay safe until next time. So thank you, Amir, for your session, and we will sign off. Thank you.
Thank you for having me.